Hello, welcome back to fractional calculus class. So today we'll be checking Laplace transform of Rn Riemann-Liouville derivative. So in our previous class we checked the Laplace transform of Riemann-Liouville integral, whereby we have Laplace transform of Riemann-Liouville integral is equal to x alpha f of x to be x squared minus alpha, then function of x. So but today we'll be looking for the Laplace transform of Riemann-Liouville derivative, which is the derivative of our integral, which gives us the Riemann-Liouville integral derivative. But however, our alpha is tends to n minus alpha f of x. So this is what we are going to do for. But however, before then, let's quickly remind us of one of the properties of Laplace transformation, which has to do with the derivative. Now we have our Laplace transformation of derivative dn dxn, which is the same thing as Laplace transform of f s power n of x of x to be to equals to xn function of x minus xn minus 1, take one of these, then f of 0 minus x n minus 2 f prime of 0, then you also have minus x n minus 3 f prime of 0 dot dot dot. You have minus f prime, so fn minus 1 of 0. So, and if we actually take the sum of this, we have xn f of x equals to summation, minus, then summation, you have k equals to 0, n minus 1, then we have s k f of n minus 1 minus k minus 1 of 0. So this is just the Laplace transform of derivative of x. So that is, with this now, with this series of summation, we can get all these terms. That is, when k equals to 0, we have x k equals to raised to power 1, and we have f n minus k, which is k0, and we're going to have this result. So when k is equals to 1, and then etc. like that. So having this series, then we can now continue with the main objective for today. So we have Laplace transform of dn dxn integral 0 to x n minus alpha f of x. So I will take the whole of this to be x. Then I will follow this pattern. I'm going to have xn f of x minus summation k equals to 0, n minus 1, sk f n minus k minus 1 0. So then I'm going to have xn. So my f of x is, don't forget, is the whole of this. which is, so this f of x will be taken as Laplace transform of integral 0 to x n minus alpha f of x. So this is my f of x, then minus summation k equals to 0 n minus 1 sk f of n minus k minus 1 of 0. So if we remember vividly in our Laplace transformation of integral or Riemann-Liouville integral, we have no, it's somewhere. Let me change the pen to write that. We have Laplace 0x alpha f of x to be x minus alpha x power minus alpha f of x. So applying that, we are going to have, let me change the pen again. So we have xn, then this we are going to have x raised to power minus, so here we have alpha, then we have minus alpha. Here we have n minus alpha, then we are going to have minus n minus alpha, then f of x. So minus summation k equals to 0 n minus 1, then we have s of k. So we can actually rewrite this, and that will give us, write this back to in differential, in dy dx function, we have d over dn, then we have dx n minus the other derivative n minus k minus 1 n minus k minus 1, and then the function is integral 0 to x n minus alpha then f of 0. Alright, so with this right now, we multiply this with this, we have x n minus n plus alpha f of x minus summation k equals to 0 n minus alpha s of k dn minus k minus 1 over dx n minus k minus 1. So here also I can write this to be minus alpha plus n. So for me to group this, then I have to take this to be minus n. So by the time I open the bracket, I'm still going to have this, then my alpha of 0. So with that, we have x n minus n, that is 0, so I'm going to have x alpha f of x minus summation k equals to 0 n minus 1 sk. So this derivative, I can write it as my d, generator d now, is 0 to x, then the order of derivative is n minus k minus 1. Then this also, this is inverse of integral, and inverse of integral gives us derivative 0 to x and I also have alpha minus n, then f of 0 dot. So I have x alpha, f of x equals to, minus so I have minus summation k equals to 0, n minus 1, s of k. So I can combine these two together, then I add up the power, then derivative is 0 to x, n minus k minus 1 plus alpha minus n, f of 0 dot. So we have x alpha, f of x minus summation k equals to 0, n minus 1 sk. So derivative is 0 to x. So we have n minus n cancel, and then we have alpha minus k, and then minus 1 of is 0. So this gives us our final Laplace transformation of our Riemann-Liouville derivative. So that is the solution of Riemann-Liouville derivatives. So in our next video, we'll be considering Riemann-Liouville fractional Laplace transform for capital fractional derivative. Thank you for watching. My name is Sunday Oluwafemi Godogbe. See you in the next video.